Numerical Series 8. Steam flows through a nozzle at mass flow rate of m dot equal to 0.1 kg per second with a heat loss of 5 kilowatt. The enthalpies at inlet and exit are 2500 kilojoule per kg and 2350 kilojoule per kg respectively. Assuming negligible velocity at inlet C1 approximately equal to 0, the velocity C2 of steam in meter per second at the nozzle exit is dash, correct to 2 decimal places. So before we solve the given numerical, let's understand the question according to the data given in the question. So in this question, it is mentioned that steam flows through a nozzle. So here for this question, the diagram is mentioned. So this is a nozzle through which steam is flowing from this side to this side. So this side we consider it to be inlet section of nozzle and this side we consider to be exit section of the nozzle. So here in this question it is mentioned that mass flow rate, that is m dot, equal to 0.1 kg per second. So this is also mentioned in this diagram here, that is 0.1 kg per second, that is equal to mass flow rate. So let's write down here as data given. So the first data we consider to be m dot, that is equal to 0.1 kg per second. Next it is mentioned that heat loss of 5 kilowatt. So this is also shown in the diagram, that is Q dot equal to 5 kilowatt. So this arrowhead indicates that this is the heat loss from the nozzle. So here we consider that heat loss to be, so this is Q dot equal to 5 kilowatt. Next it is mentioned that the enthalpies. So first we consider the enthalpy at inlet section. So that is defined as H1 in the diagram, and it is given that H1 equal to 2500 kilojoule per kg. Another enthalpy that is mentioned at the exit section, that is H2, is equal to 2350 kilojoule per kg. So let's consider enthalpy at the exit section, that is H2 is equal to 2350 kilojoule per kg. So in this question it is mentioned that assuming negligible velocity at inlet. So velocity is defined here as capital C. So at inlet the velocity is assumed to be 0. So as per the question, C1 is equal to 0. And next, so here for this question we are going to calculate the velocity of steam, in meter per second at the nozzle exit. It means this C2 we have to calculate here. So simply write down the velocity at exit as C2 is equal to question mark. So this we are going to calculate for the given question. Now we will see the diagram that it is clearly visible from the diagram that it is a case of steady flow. So as it is a case of steady flow, so here we are going to use steady flow energy equation. Steady flow energy equation. So the expression for steady flow energy equation is m dot h1 plus c1 square by 2 plus z1g plus q dot is equal to m dot h2 plus c2 square by 2 plus z2g plus w dot. So see here the velocity is expressed as capital C. That's why in kinetic energy we use the C term here. So that is C1 square by 2, and in right hand side that is C2 square by 2. So here in this question we assume Z1 is equal to Z2. So this we are going to assume here as nothing is mentioned regarding the potential energy. So as Z1 is equal to Z2 according to our assumption, so we neglect this Z1G and Z2G from both the side of the steady flow energy equation. Next, the C1 is given in this question is approximately equal to 0. So here simply we cancel this C1 square by 2 as 0. Next, in this question there is nothing regarding the work done on the system or work done by the system. So simply we neglect the work done here. Next, we consider the reduced form of equation as m dot h1 plus q dot equal to m dot h2 plus m dot c2 square by 2. So see here we have m dot that is given in the question, h1 is given, h2 is also given, q is given in the question. So if we put all this magnitude in this expression, we get the magnitude of C2. So now let's put all the magnitude in this equation of steady flow. So here we consider m dot as 0.1 into enthalpy is 2500 plus q dot. So see it is a heat loss to the surrounding from the system. So it is given 5 kilowatt. So as it is a heat loss, so we use a minus sign as the sign convention for heat interaction. So here we consider it to be minus 5. So that is equal to m dot is again 0.1 into H2 is 2350 plus m dot is 0.1 into C2 square by 2. Now here we have to take care of the units. It means we have to balance the units with all the energies. So here see the enthalpy is given as kilojoule per kg. It means kilo term is there. Mass is given in the rate of mass flow is given in kg per second. The heat loss is mentioned in kilowatt, that is kilojoule per second. So all the kiloterms is there. So we have to make sure that the kinetic energy is also remain as kilojoule. So for that we have to divide 1000 with the kinetic energy. So to just balance the units of all the energies. So after solving this equation, so we get C2 as 447.213 meter per second. So as in the question it is mentioned that correct to 2 decimal places. So it means we have to consider C2 as 447.21 meter per second. So this is the final answer for the given question. Thank you. See you in the next video.